All right, welcome to the second video for the week. This is going to be 12.4. This is slightly new stuff for you. So one thing you are going to need is your calculator today. So you can see that up in this little box for you right here. You're going to need your calculator today. All right, so making sure you can get that and use that. All right. All right, so here we go. It says we want to start with greatest common factors. Now remember, greatest common factor to a set of terms is the common factor with the greatest coefficient and greatest exponent. It must be common to all terms, okay? So basically, you're trying to find a number that goes into everything or a variable that goes into everything, right? So factoring out a GCF from an expression is like undoing the distributive property or performing the distributive property in reverse. Now, we're going to do some factoring and all that here towards the end of the year. Well, here shortly anyway. And so this is stuff that you should know how to do already. All right, so the first one is factor out the greatest common factor for each of these expressions. Well, if 2x plus 6, well, the only number that can go into either 2 or 6 is simply 2. So I know that 2 is going to be my greatest common factor. There are no x's with both terms, so x does not have a greatest common factor. It's just going to be a tag along. And when I pull out a 2, what am I left with? Remember, I'm always reverse distributing, right? And you all know how to distribute, so that should be pretty easy. So if I take a 2 out of 2x, what do I have left? I simply just have x. Plus comes on down. And if I take 2 from 6, what's left over? Well, in essence, 6 divided by 2 is what? 3. So I know that I have 3 left over. That is GCF in a nutshell right there. Okay. If I look at this one, I have 3x squared plus 9x plus 12. Well, there are only x terms with the first two, not with the 12, so I can't pull an x out of any of that. And what number goes into 3, 9, and 12? You got it, 3. So I'm going to pull 3 out. And when I do that, what am I going to have left over? Well, I'm going to simply have x squared left over. I'm going to have 3x left over. And then I'm going to have 4. And how do I know that? Well, 9 divided by 3 is 3, and 12 divided by 3 is 4. So that's what's left over. When I look at C, I've got a 4x squared and an 8x. Well, 4 can go into 8, so I know that. So 4 is going to be my greatest common factor. And then I've got an x squared and an x. Well, the only common one between those is x. So I'm going to pull out a 4x. When I do that, what do I have left over? Well, x squared divided by x is x. Remember, same base divided by same base, I subtract, right? If I pull 1 out of 2, how many do I have left? 1. So I know I simply have an x left. And if I pull a 4x out of 8x, I don't have any x's left because x, if I pull an x out from an x, I have no x's left, right? So basically 1. And then 4 into 8, 8 divided by 4 is 2. So I know this is going to be x plus 2. And the last but not least, 36x squared minus 6x. I'm going to pull a 6x out. I should have a 6x minus 1 left over. That is GCF in a nutshell. And we're going to do more of that here in a couple weeks, all right? Now, problem number 2 basically states that a group of students are working together on the problem shown. Write a quadratic function in factored form to represent a parabola that opens downward and has zeros at 4, 0, and -1, 0. Okay, so their zeros are at 4, 0, and -1, 0. So I know that I'm going through -4 or I'm going through positive 4 on the x-axis and going through -1 on the x-axis as well, okay? And I want it to open downward and have those zeros. So the question is, we want you to use your graphing calculator to graph each student's function, sketch a picture of each graph next to the student's functions, making sure to accurately graph the zeros in direction of the graph. Now, if you don't have a calculator at home, You can get online and get a TI-84 for your computer right now. Texas Instruments are basically letting you download that software. Okay, so there are a lot of free graphing calculators available for you on your computer right now. So if you need that, get it. Otherwise, I'm going to pause this and I'm going to work on this myself and then unpause it because you should be doing this. All right, so I'm pausing right now. Go to work. All right, welcome back. Yours should look a lot like mine. I use my graphing calculator to do it, and some of them are thicker than others. Remember, we're just kind of trying to sketch this, right? So we're not trying to get all fancy with it. But yours should pretty much look like mine. So if you need to pause this and double check, do that now. Otherwise, I'm going to keep going. So we're going to answer some questions based on that information. So it says, what are the similarities amongst all the graphs? Well, they're all parabolas, right? They're all parabolas, right? Now, what are some of the difference among them? Well, they're varying widths, right? Some more narrow than others, right? Some are wide, right? They're wide. Now, there are also 4 that open downwards. That was something you could have noticed. And 2 open upwards. Those are all things I could have noticed, or I did notice. Question C says, which students have correctly written an equation? How is it possible to have more than one correct equation? All right, so I know for a fact in looking at them, and I'm kind of referring back to my sheet here, so as I do this, okay, so I've done that. Instead of flipping up and down on there, I'm going to refer back to my sheet. I know that Judy's is definitely incorrect. And how do I know that? Because it opens the wrong direction. Opens, right? It opens, no, it opens the right direction, right? What it does, sorry, and I'm looking at the wrong person as I did that. Jody's is at -4, +1. So she is at -4, 0, and 1, 0. Well, what should she be? Well, she should be at 4, 0, and -1, 0. So she's got it moved along the x-axis the wrong direction, right? So that's definitely incorrect. Now, there's 2 more that open upwards. We talked about that. I've got Tim and Michael. So Tim and Michael are incorrect. Why? Well, they open the wrong direction, right? They open the wrong direction. They're opening upwards. They should be opening downwards based on the directions, okay? And so what does that leave me? Well, it leaves me with 3 that seem to meet the criteria. And how is that possible? Well, we'll explore that here in a second. So let's get to that. Which students have written equations that are correct, right? And why are they incorrect? That should say correct and not incorrect. So I'm going to kind of modify that. That should say correct. Okay, that should say correct and not incorrect. And why are they correct? Well, I should have caught that before now. So which students written ones that are correct? Well, that is Maureen, Diane, and Tom. Okay. Oh, I saw what I did there. I flipped them. Ugh, I hate doing that. I should have done the correct ones first and the incorrect ones secondly, and I flipped them. So C and D really should be flipped, okay? So Judy's is incorrect. Tim and Michael's is incorrect. Why? I already told you about Judy's. Michael's, the wrong direction. This is what I get for using someone else's notes and not mine as I do this. So which students have written equations that are correct? Well, that's Maureen, Diane, and Tom. Now, why or how do I know that they're correct? Or why do I think that they're correct? Because they met the criteria. They met the criteria. And the criteria is simply that they needed to open down and they needed to pass through -1, 0 and 4, 0. They met those criteria. It opened correctly and had the correct zeros. Okay. That's how I know. Now, how many possible functions can you write to represent the given characteristics in the plane of reasoning? So how is it that there could be more than one? Well, it all falls to the A value, okay? Because there's an infinite number of possibilities here. And the reason why there's an infinite number of possibilities is because the A value can be any number, right? The A value could be a -1. It could be a -10. It could be a -300. It could be a -1/10. It doesn't really matter what the A value is. As long as I have my roots correct, the A value can be any value there. Okay? So all the A value is going to do is dictate how wide or narrow this parabola is. So the A value makes the width, right? It determines, it determines, come on, right? It determines how wide, okay? That's the importance of the A value. Not only is it negative or positive, so it tells you max or min, opens up or down, but it also tells you how wide or narrow your parabola is going to be. All right, so moving to the next part of this, and that is a quadratic function in factored form is written as the function that I have written there for you, and I'll rewrite it just so you can see me write it. And that is my A value is always going out front, and then it's going to be x minus r1 times x minus r2. Now, this is called factored form. There are three forms for parabolas, for quadratics. Standard form, and this is our factored form. We're going to see vertex form here soon enough, okay? But three forms, and they give you wildly different pieces of information, okay? In this case, what does the sign of the variable a tell you about the graph? Well, it tells us if, and I'm going to change colors, I'm getting sick of black. It tells us, does it open up when a is positive, and it opens down if a is negative, right? So it'll look like that, or it'll look like this, which means this would give me my min, and this would give me my max, right? Yeah. So how do you think the value of the A affects the shape of the graph? Well, I've been kind of covering that for a while, right? And that is it determines how wide or narrow it's going to be. And here's what it is. Ready? If A is greater than 1, the more narrow the parabola. Okay, so the bigger the value gets, and it doesn't matter negative or not, right? The negative doesn't tell you anything about that. It's not -3 is wider, 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 right? It is the negative or a positive doesn't have any bearing on how wide. It's the actual number. So if it's 10, it's going to be so much more narrow than 1 is. 1's pretty standard. If it's a half, it's going to be really wide. So if A is less than 1, right? Less than 1, meaning a fraction. The more wide the parabola. Okay, the more wide it is. Remember, it's not the negative. The negative or positive doesn't determine this. Simply the value. Okay? Now, what does the variables R1 and R2 tell you about the graph? Well, hopefully you figured out that they are going to be my zeros slash my roots. Okay? Meaning this is that I know that if I could take x minus R1, that's the function, right? So my function is x is this right here. It's f of x equals, get down, collapse, a outside of x minus R1 times x minus R2, right? Now, if I take that x minus R1, remember, we use the word zeros. Why? Because if I take x minus R1 and set it equal to 0, I can solve for x, which gives me my 0, okay? So I would simply add R1, and x is equal to R1. That is my root. That is my 0. Be the same for the other one. X minus R2 equals 0. Add, and x equals R2. The reason why this form is so important is it gives us our zeros. It gives us our solutions. It gives us our roots. Okay? All right, so let's do a few of these so you get it. Okay? And this will be our last page. Okay? So here we go. Use the given information to write a quadratic function in factored form. A is outside of x minus 1, R1 times x minus R2, right? Oh, I went too far. Sorry. There you go, what I was reading. So now, the parabola opens upward, and the zeros are 2, 0, and 4, 0. Well, when I look at that, I know I can write any function, right? So I know that this, and I'm going to start off nice and easy. This is opens upward, so it's got to be positive. And all I know is my zeros are 2, 0, and 4, 0. So I could have x minus 2 and x minus 4. And the reason I know that is that if I take x minus 2 and set it equal to 0 and I solve for x, it's going to be x equals 2. Hence, it's always going to be opposite of what you think going in and out. Okay? Now, since we kind of saw this at the beginning, it doesn't matter what my a value is. So I could write this as this, or I could write it as this. The bottom line is the a value has no bearing with this. All I need to know is that my a value is positive and my roots are at 2, 0 and at 4, 0. So any value can be for a there, right? A can be any. Let me change colors so we can get this. A can be any positive number, okay? I could have written it as f of x equals 1/2, also x minus 2 and x minus 4. It doesn't matter to be a whole number. It could be in a fraction as well out there. All right, so the next one, B, The parabola opens downward and the zeros are at -3, 0, and 1, 0. So -3, which means it's got to be positive inside, right? So it's got to be something like x plus 3 equals 0, because if I solve that, then it's x equals -3. So I know when it goes inside the parentheses, that's got to be a plus, okay? So as I do this, it can be any of these. So here we go. F of x equals, and in this case, it's opening downward, so it's got to be a negative. So negative x plus 3, x minus 1. Or, and let me change colors here. It could be f of x equals a -1/2 outside of x plus 3, or x minus 1. Or, as long as it is a negative out front and I have x plus 3, it could be any of those as long as my a value is a negative number. Okay? Now, how about C? The parabola opens downward and the zeros are at 0, 0, and 5, 0. Now, this one's a little funky, okay, but not too difficult. Once you see it, you'll get it, okay? And that is, we know that x has to be equal to 0 for one of them and x is equal to 5 on the other. So it's got to be x minus 5 in one of them. All right, so here's how we would do that. I'm going to write it as I see it, okay? And it opens downward, so it's got to be a negative, okay? So f of x equals, and I'm just going to say a -1 outside of x minus 0 and x minus 5. Okay, now x minus 0 is just what? Well, it's x. We don't write -0 for anything. So that really becomes just negative x outside of x minus 5. Okay, now remember, we're taking each x and setting it equal to 0. So negative x equals 0 just becomes x equals 0, right? 0 can't be negative or positive. Let's do another one, just so you can see it. F of x, it can be any value. So let's say -6 outside of x minus 0 and x minus 5. Well, x minus 0 is just x, and -6 times x is -6x equals, or not equals, but times x minus 5. It will not matter what that ends up looking like as long as the a term here is negative with an x out front with it, and then x minus 5. Okay? All right, so let's do a couple practice problems. Number 4, use a graphing calculator to determine the zeros of each function, then write the equation of the function in factor form. So I'm going to assume that you're going to do this, but here I'm going to help you with this a little bit, okay? Look at this. This is in standard form already. And you're going to put this into your calculator and find the zeros, right? You're going to find when y is equal to 0. So whatever the x value is when y is equal to 0. But let me give you a reminder of something. Look at your first term. Look at your x squared term, because that gives you your a value. In this case, the first one, a, where are you going? A is equal to 1. When I put this into my calculator, I'm going to get my zeros. Sorry, it's on the table, funky. My zeros are at 2, 0, and that's 6, 0. So if I want to write this in factor form, I know my zeros, I know my a term here. So all I got to do is plug. So f of x equals 1 outside of x minus 2 and x minus 6. So really, that is simply f of x equals x minus 2 times x minus 6. Okay, I don't need the 1 out front. I just write it so you guys can see it and understand that. All right, I'm going to hit pause and let you do the next two. Make sure that you get your a value first, plug them in, and then I'll show you what everything else is. All right, be back in a minute. Make sure you do these. All right, welcome back. Hopefully you got what I got. Now you notice that I have the A term listed out first. That's really important when we're doing this. It tells me up or down. I graphed these. It gave me where the zeros were. I could use that by the table or just simply looking in the graph and counting over. And then I'm plugging and going from there. All right, last but not least, let's do number 5. Here we go. Write the function in factored form if it is not already. Hint, factor out the GCF. That's a big hint here in the directions. Then without graphing, determine the zeros of the function until whether the graph of the quadratic will open up or down. So when I look at this, I want to factor out a GCF. So I look at the first one and I see 2x squared plus 6x. So if I factor out a 2x, my GCF, I'm going to be left with x plus 3. Now, if I look at this, is this in factored form? It is, okay? So my factored form here is going to be f of x equals 2x times x plus 3. That's in factored form. My zeros here are going to be at 0, 0 because the 2x equals 0, right? 2x equals 0, divide by 2, 0 divided by anything, 0 divided by 2 here is 0. So I know one of my zeros is at 0, 0, and my other one is at, you guessed it, negative 3, 0. And is this going to open up or down? Well, it's going to open up. And how do I know? Well, because my A term, the 2 on the 2x squared at the very beginning, or the 2x here when I factored it, or both of them are positives. Therefore, it has to be opening up, right? So it has to have a min. All right, I'll do one more with you, and then I'll let you do C on your own, and then we'll be done for the day. Okay, so when I look at this one, I see g of x equals negative x plus 5 and x plus 1. Well, the only thing I could do is factor out a negative 1 to make that x a positive. So if I factor out a negative 1, that's going to end up making this an x minus 5. And it doesn't do anything to the last one. Okay, so when I do that, am I in factored form? I am. So I'm simply going to put it as f of x equals negative 1 outside of x minus 5 and x plus 1. My zeros in this case are going to be 5, 0 and negative 1, 0. And I know I'm going to open up down. And why do I open up down? Because my A term is a negative. That negative out front, right, makes it opening down. All right, I'm going to let you do C on your own. I'm going to pause you so you can get it done. And then when you come back, it should be matching yours. Okay. Okay, welcome back. Hopefully you got what I did. So the first thing I would have done is I know that there's nothing on the x plus 4, and I'm going to do highlighters as I talk about. There's nothing to factor out with x plus 4. There's nothing there to factor. There is no GCF whatsoever. But when I look at the negative 3x minus 9, when I look at this right here, the negative 3x minus 9, I know that I could factor out a negative 3, okay? And remember, I don't want x's to be negatives. I want them out front. I want them not included inside the parentheses, right? Inside of the binomial. So I want that 3 outside. So when I pull a negative 3 out, the only thing I have left on the front is an x. And then if I pull a negative 3 out from a negative 9 divided by negative 3 is a positive 3. So therefore, plus 3. Okay? You can see my factored form. You can see my zeros and the fact that it opens down. I hope you enjoyed this lesson. Hopefully you are adapting to this new learning model. And my office hours are always open, so please stop by if you need to come and see me. Otherwise, have a great rest of your week. Remember, everything will be due on Friday at 11:59 p.m. on Friday, the 10th for this week. All right. Have a great week. Bye-bye.